So recently, one of the things I've been involved in is helping make face shield components on a 3D printer. Now, how my printer works is you have a hot end, which is a bit like a pen, but instead of depositing ink, you're depositing melted plastic. Motors feed plastic filament into the hot end. This orange part is known as the heat block, and that's responsible for melting the solid plastic. The force from the motors pushing the material down then allows the nozzle to extrude out molten plastic. This hot end is mounted on rails that allow it to move, and how 3D printing works is that your three-dimensional part is built up of many thin layers stacked one on top of another. Your hot end, your pen, essentially, draws out and then fills in each thin layer that your model is made up of, then moves slightly upwards, drawing the next layer on top of the last until you make the whole part. Now, the aim was to make as many of the face shield components as quickly as possible. So how did I try to minimize the time it took to make one of those? Well, it takes time for the hot end to travel around, print a layer, move slightly upwards, and then print the next. So one of the things that you can do is just to make this hot end travel faster, because printing a layer quickly like this is going to take far less time than printing a layer like this. Now, remember that 3D prints are just made up of many thin layers stacked on top of one another. So another thing you can do is just to make it print thicker individual layers. That means that for an object of a certain height, you'll need to print fewer layers, and then your part will be done printing faster. Now, finally, another thing you can do is just to print wider lines, because remember that the hot end is tracing out the shape and then filling it in. So imagine colouring in a shape with a thin pen compared to a thick Sharpie. Your Sharpie is going to be faster. All of these essentially mean that more material has to pass through the nozzle in a given amount of time. Now, unsurprisingly, there's also a limit to this, which is how quickly you can melt your filament. Once you go over that limit, you're not allowing yourself enough time to melt the plastic, which means it won't flow as well. And then when you try to print with that, you'll end up with holes and gaps in your part, which is not what you want. So, in summary, how can you decrease the amount of time it takes to print one of these? Well, it's a balancing act between increasing the speed that you print at and the volume of plastic you extrude as you print, whilst also making sure that your printer can still melt the plastic you need in time.